We are on to our next section of notes, 10.2, finding arc measures. So let's go through our set of definitions, as well as go through core concepts, extra examples, puzzles, and etc. So our first definition is a central angle. And this is an angle whose vertex, or the center, of the circle. So a central angle is an angle whose vertex is the center of a circle. So vertex and center, they mean the exact same thing. A minor arc is where if it measures less than 180 degrees. So a minor arc is if it measures less than 180 degrees and it lies on the interior of a circle. Now I will draw pictures of this momentarily, but let me get through major arc. Major arc are the measures of the exterior. So for example, I'll put it up here. If I had a circle and I had a piece of it, kind of like a pie, there's my central angle. No, it's not drawn to scale. Then this part is your minor arc. This part's your minor arc. And the rest of this becomes your major arc. So arc is the edge. Okay, so let's move on to semicircle, and that is the arc with endpoints that are endpoints of the diameter. That's pretty much like the arc of half of the measure of the circle. So if I had a circle and I cut it in half, so as a semicircle, this arc here towards the end, or half of it, this arc here is 180 degrees, and that's that arc, or a semicircle. The measure of a minor arc is the measure of the central angle. And the measure of the minor arc is the difference of 360 and measure of related minor arc. We'll do an example of that one later. Adjacent arcs are two arcs of the same circle and adjacent, meaning next to. Congruent circles, well, two circles are congruent if and only if. So two circles are congruent if and only if a rigid motion or composition, also known as transformation or a combination of rigid motions, maps, this one's a long definition, maps one to another. So two circles are congruent if and only if, which is a biconditional statement, a rigid motion or composition of rigid motions maps one to another. So another way to shorten this is a transformation happened. So it either flipped or rotated in some kind of form or fashion. And congruent arcs, circles are congruent, or arcs can be congruent if and only if, another biconditional statement, have same measure, the same measure arcs of the same circle, and they are congruent circles. Congruent circles, that's a G. Similar arcs, or circles can have similar arcs if and only if, another biconditional statement, they have the same measure. So similar arcs, same measure. So we'll get to know the difference between all of these in the examples that we go through. So the measure of a minor arc is already here, is the measure of its central angle. And so it's already expressed here. The minor arc is with the central angle, so 50 degrees. Then the measure of the major arc is the difference. So if I were to take 360 minus 50, I get 310. So that means this entire arc here is 310 degrees. So if this is 50 degrees here, then the arc is also 50 degrees. Alright, that's one way to do our examples on measuring arcs. So let's go on to our next page. Okay, if we flip over to the next page, we're going to talk about a couple of postulates and theorems. So our first postulate is the arc addition postulate. So the measure of an arc formed by two adjacent arcs is the sum of the measures of two arcs. So if I wanted to add or to figure out the circle ABC, I just need to measure AB plus BC, and then I get ABC in this case. So, for example, I want to find GE. So if I wanted to find GE here, if I want to find GE, I'll highlight it. Then all I have to do is add my two measures. So the 40, which is this arc length, and 80, which is this arc length. So 40 plus 80 is going to give me 120. So this entire arc length of GE is 120 degrees. If I wanted to find GEF, so I wanted to go all the way around. So then I already found GE, I need to include F. So all I do is add 120 plus 110, and I get 230 degrees. And if I wanted to find just GF on the other side, so this is what I want to find. I've already found these up to be 230, but our entire circle measures 360 degrees. So all I have to do is subtract 360 degrees from my measures that I've already added together, which was 230. And I get 130 degrees. So that is an example of how to use arc addition postulate. So now we have our theorems, congruent circles theorem. So these circles are congruent if the radius is congruent. I didn't do an example on that one because that one is pretty much self-explanatory, especially since they have very similar central or centers. So now we have an example for congruent central angles theorem. So if it's in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So I have three examples here, and I have to tell if they are congruent by using congruent central angles theorem. So I have D, E, F, B, and C, or this entire example for A. So in this case, I have two arc lengths that are the same. So if this was 80, then the arc length here is 80. And if this was 80, then as well, then EF is 80. So I know that CD is congruent to EF, and they both share a central angle at B. So these two are congruent. These two are congruent. So you can say C, C, A, T, because they share B. And their arc lengths are the same. Now for our second example, even though they share a central angle, Q, and we assume that this is 90 degrees, but the arc length itself is not the same because they're overlapping. It would have been one thing if they were just, you broke up in one circle, but just because they're overlapped doesn't mean they're the same. So our S is not congruent to U. But even though they share Q. They might share point Q, but the two arcs are not the same. You can tell this one's a little bit longer than the other, so these are not congruent based on this theorem. Now let's look at our other one. They do have very similar central angles. So 95 and 95, and they have a congruent radius, or there are congruent circles based on the radius. So these are congruent circles because TB is congruent to XZ and similar radius by congruent circles theorem, which was the first theorem that we talked about. So these two are congruent, whereas this one was not based on the arc length. Okay, and then our last one is semicircles theorem. All circles are similar. Doesn't mean they're all the same or congruent. So let's go on to our next one where we can apply a lot of these examples. So we're on to our next page where we have extra practices. It's the best way to understand circles is always practice, practice, practice. So number one says you need to find the given arc as, or identify it as a major arc, minor arc, or a semicircle, and then find the measure of that particular arc. So in this case, I am looking at AB. And AB, if I were to tilt it a little this way, looks very much like a right angle. So if angle E, or AEB, is 90 degrees, then my arc length is 90 degrees. So that means AB is 90 degrees, and it is a minor arc because it is less than 180. Or it's less than 180. Number two, you're asking for A, B, C. So this time we're going all the way around. So we have A, B, and C. And again, we have this much. So this side's 90, my other side's also 90. But I'm looking for A, B, C. So 90 and 90 gives me 180. And 180 is an actual semicircle. Number three, I'm looking for ABD. So I'm going from A to B all the way around to D. So now I'm adding in this 40 degrees on it. So I have 90 plus 90, which we already said was 180, plus another 40, and I get 220 degrees. Now, is it a major arc, minor arc, or a semicircle? In this case, it is a major arc because it's over 180 degrees. Now let's look for BC. I want to just find from B to C, which we already found to be 90 degrees, and is a minor arc. Number 5, we're looking for BAC, so we're going the other direction. So we have 90 here. Well, let's find this missing piece here. So I have full 220. And I want to find this piece here. So I would take 360 minus 220. I get 140. So if I wanted to find B, A, and all the way around to C, so if I wanted to find B to A to C, I would have to add 90 plus my 140 plus another 40. I get 270 degrees. And 270 degrees is definitely over 180, so it is a major arc. Now, number 6 says find DAB. So I'm going from D to A to B. Well, all I have to do is add 140 plus 90. And 140 plus 90 gives me 230 degrees. And 230 degrees is a major arc. Number 7 is find AD. And we kind of found AD already in order to find some other parts. And we found it's 140, but because it is less than 180, it is a minor arc. And CD. You need to find CD. It is 40 degrees and is a minor arc. Oh, I'm sorry. Alright, so that is 1 through 8. I'm finding minor and major arcs. Number 9. You have a diagram here that we're using again. So that's one. And it says explain central angle E above. To tell whether ABC, so you're looking at ABC, is it congruent to ABC? And in this case, we know this is 80. So ABC is 180 degrees. And we know that ADC is 140 plus 40, which also gives me 180 degrees. So yes. Especially since AC is a diameter. Number 10. We have central angle K, or center K. We need to find the measure of DE. So we're going from D to E. What we know is that CE is a diameter. And if it's a diameter, that means that from E to C, it should equal 180 degrees. So, let's find BA first. Okay, So we know that CE is a diameter, but we can also use theorem 10.4, the congruent angles theorem, which shows us in the same circle or in congruent circles, two minor arcs are congruent if and only if the central angles are congruent. So obviously ED it's not congruent to this side. However, AKE is very similar to DKC. So this side is also 55 degrees. So now we know that this semicircle is supposed to be 180. So we take 180 minus 55 and get 125. And if it asks us to find our central arc BA, it would be 95, just as a bonus. So this was based off the congruent central angles theorem. Okay, so that is how that would be used. And our last one, number 11, it says find the value of x and find the measure of AB. Well, we have all our measures given, but we know all circles add up to 360 degrees. So I will take each value, add them up, and set them equal to 360 degrees, just like I would a triangle or a quadrilateral. So 5x plus 40 plus 70 plus 75 plus 2x equals 360 degrees. Okay, so adding like terms, I have 5x plus 2x, and then I have 40 plus 70 plus 75 gives me 185. Subtract 185 from both sides. And I'm left with 175 divided by 7, which gives me 25. So x equals 25. So we got to that part. Now we need to find the measure of AB. And AB is here. So if AB equals 5x degrees, we plug in 5 times 25, and I get 125 degrees for AB. And that concludes our notes for 10.2 on arcs and semicircles and measures of those arcs. Your next page is a puzzle, and what fruit is always in a bad mood? So this will be your puzzle, as well as you'll go straight on to 10.3. There will not be a worksheet. It's tied in after 10.3, and that is all for 10.2. Thank you.